compact way of describing the behavior of this system. Notice that the verbal explanation of the things that happen was fairly extensive, and if it were to be in text form, could very well span a couple pages of the document, requirement specification, for example, and it would be difficult from inspection to know whether something had been left out. There's the diagram, and you can look at it and verify by walking through it as we just did. Yep, sure, everything is there, everything that needs to be there is included. Or you might find that it's not, and then something can be added to the diagram. Okay, so how do we derive tests? Well, to achieve the basic state and transition cover, derivation of tests is fairly straightforward. What we want to do is, first off, adopt a rule about where the test must start and where it may or must end. So you could say that the test must start in an initial state and may only end in a final state. Now, the distinction there between may and must is that in the case of may end is that if you could go into that final state, and if there's a way out of it back to some other previous state, you could loop back and the test could continue. The test must end when it enters a final state. That means that that test has to end there. Okay. It's important to have these rules about what constitutes a test in these cases because with the possibility of looping, then the test could be of arbitrary length, and you want to have some way of saying, well, this is a test, and this is a test, and this is a test, and they're separate based on that rule. Okay, so with that rule in place, and then this one is pretty typical, the one shown here, you then define a whole sequence of event or event condition combinations that lead you to a allowed test ending state. And we're going to want to capture at the very least the expected action as the expected result for each transition. If it is possible to directly or indirectly observe the state that the application is in, then that would also be part of your expected result. Now, to keep track of what you've covered, it's very simple. If you've got a printout of the diagram, you simply mark off the states and the transitions as you go. So using a highlighter or a marker or something like that, just as I showed in the previous slide, as I was going along, I was using the yellow marker to mark things off. That's a pretty good way to do that. And then you repeat steps 2 and 3 over and over again until every state's been visited and all transitions have been traversed, and then you know that you've achieved that, that degree of cover. Okay, so let's take a look at an example. Say that the test must start in the initial state and must end if it enters the final state. So to generate the first test, we start off browsing. We click a link, display, add to cart, selection dialog, and so forth. You see walking through the entire diagram here, state transition diagram. And notice that I'm looping where I can, right? So I've got the login bad, login good, purchase bad, purchase good. Those are shown here. Now, what that will do if you take any loop that you can as you work through and derive the tests, you'll tend to minimize the number of tests that you create and maximize the number of events that occur in a single test. Now, that's fine if you feel that the system is relatively stable. If you think that the system has a lot of bugs in it and you want to have very fine-grained tests that test a few things together, then you would actually say, well, I don't want to do these loops. I want to actually have, for example, a separate test for the login bad and the purchase bad. Okay, each of those a separate test because I want to know if those aren't handled properly that there's the proper error handling occurs, right? So that's another thing. It's a judgment call for the tester. You just have to decide, do you want big coarse-grained tests or do you want small fine-grained tests? And it's usually about traceability of the test results back to a limited set of conditions. Okay, so after this first test is run, you see the coverage check here. Notice that the things which have been covered, the transitions and the states, are shown with dotted lines. The guys here, the abandons, as you can see, are not covered, neither is the go elsewhere. So we've got to do a little more work. Okay, so deriving the rest of the test, here's the first test again, just for reference. And now I'm going to abandon from the selection dialog. Test 3 abandons from the login dialog. Test 4 is going to abandon from the purchase dialog. And then finally, test 5, rather than going back and browsing, again, is going to do the go elsewhere after the confirmation. Okay. And based on those additional 4 tests, I've now achieved complete coverage. You see these are all shown with dotted lines now. I have to kind of squint at that back there, but see if they're lighter in color. And if you've got really good eyes, which I used to but don't anymore, you can actually see that there's different color coding to these lines that shows traceability back to the specific test. If you want to have traceability back to the specific test numbers for whatever reason, you could always write the test number on the transition or the state, just so that you keep track of this is where it's covered. Though usually that's not going to be necessary. It's more that, you know, satisfy yourself that you have covered it, not that you're, you know, which test covers it. Okay, now it's a good idea to try to keep these diagrams simple. Now, you can't always keep them so simple that they'll fit on a single PowerPoint slide. Obviously, I had to do that for this example, but you don't want them to be enormous and complicated. But of course, systems in the real world are enormous and complicated, right? So what do we do when we have a very complex system? Well, usually what you try to do is encapsulate some complicated actions as sequences of events and actions, excuse me, as a superstate. Okay, so the example here in this particular diagram is the purchasing state is actually a superstate. Because purchasing, as those of you who use e-commerce systems will know, consists of a sequence of screens that you go through, not just one screen. So we can expand out the superstate of purchasing into 3 substates as shown here. This is based on a fairly typical e-commerce system. We have the first screen that comes up, which is the entering address, and then we have the specifying the payment mode, and then finally the editing of the order, if desired. And notice that the inbound event, or the inbound transition, excuse me, here is the same, and the outbound is the same. So this whole thing inside this dashed box here is nicely encapsulated. See that? Nice